Good to see you all. So let me tell you that what are the topics that I am taking up. I got a list of so many topics when I got the training needs analysis done that I was surprised that probably I will have to then go on training for the entire month to be able to complete such a large number of topics. So what I have done, I have taken some important topics which are more complicated, more complex, because you might get training or you can self train on the other topics, and maybe we can meet some other time next month or the following month. But these are the topics which I thought should be taken up on priority. So I'll be taking up the Geographical Information System, GIS, to begin with, and then we will go on to the other topics. So without delay, let us start doing that. I'll share screen with you. All right. So we are beginning with the topic of GIS. Please feel free to interact whenever you want to talk, whenever you want to give your opinion, whenever you want to raise a question or discuss something, feel absolutely free because that is the format for this training. So GIS, as you are already aware, is a geographic information system. And what does it do? It gathers, manages, and interprets data. And my dear teachers, you know that today is the time when everything in the world is working on data. And data management system itself is a very big system. So what is geographical information system? Obviously, it has to do something with geography. It has to do with the landforms, with the landscapes, from where we are gathering the information and then transmitting it for better analysis. So it analyzes spatial location and organizes layers of information. And why I say layers of information? Because sometimes from a particular landscape, you can have a lot of other information as well to be able to visualize maps and 3D scenes. So it is today one of the leading tools for defense services to be able to understand where their armies are stationed and where the enemies are stationed. And so geographical information system is today becoming a very important system for dealing with the present situations. How GIS works. So GIS technology applies geographical knowledge to gain intelligence and actionable intelligence from all types of fields such as maps, data, analysis, and apps. So here comes that what are the various methods for the GIS to collect, infer, analyze, and interpret data through maps which come from GIS, through the actual raw data which comes to GIS, analyzing the data, and also the apps. There are wonderful apps, and we shall be also looking at some of them during this program. We then go on to the maps. Maps are so important. A geographer without a map is like a painter without a brush. So maps are important and everyone understands and appreciates good maps. What GIS does, it creates wonderful maps every day, which provide basic experience and a practical interface for the application of GIS. So that's the primary way in which the GIS users can share their work with the others in their own organization and beyond. Because GIS the data it collects, it is not for a particularly limited area or a country. It is shared by a lot of other countries. I'm sure you all know that the storm warning systems, the cyclone warning systems, the cyclones can be coming anywhere in the world, but whoever is collecting information, developing information, it disseminates to the rest of the world. A lot of times, India has been warned about the cyclones from the US intelligence system, US GIS system. So we can see that GIS is not only confined to a particular area, but its maps spread the entire length and breadth of the world. So maps are the primary way through which GIS can share the data. And they're very critical because maps can be both analytical and artistic. Now, why analytical and artistic? For analytical maps, you will have to see that what are the various pointed or focused things that you're looking at in a particular area. Are you looking at the drainage pattern of a region? Or are you looking at the rock structure of a particular region? If you are, for example, wanting to dig oil, you would like to know what is the underneath rock structure, whether it is jointed or less jointed. Is it sedimentary or metamorphic or igneous? Obviously, it is not easy to drill an oil well under the igneous rocks because oil is primarily found in sedimentary rocks, and yet you can go wrong in thinking that petroleum is found somewhere. So maps carry a very, very universal appeal to everyone and offers a complete clarity and shape to the world. And they enable you to explore your own data that you have collected and to discover patterns into it. It's very interesting. You've seen, I'm sure that you're all geographers in your own way, in your own places, in your own schools, that how a rainfall map, you keep rainfall map on one end, vegetation map on the other, and you superimpose them. Have you tried this? That you put them on a cartographic table with a glass and a light underneath, and you superimpose vegetation and the rainfall pattern. It's a very interesting way you can identify the patterns emerging from that. Just like the rock type and the actual petroleum which is already discovered and the petroleum which is potential. All this can be made to be understood more clearly through maps. And make no mistake, traditional printed maps are not going away in spite of your best of ability, in spite of your best of knowledge that you have of technology. One thing is there, that the traditional printed maps will always be very important in the world. They will continue to be important because they help you quickly grasp the broader context of a problem or a situation. And they're actually truly a work of art, because those who have worked with maps know that maps can actually work and stir your emotions and imagination. There's no comparable large format document that communicates and organizes so much of data, so much of information, so effectively and so beautifully. So cartographers using GIS will continue to use their craft of making astounding printed maps that teach and amaze. I'm sure that all of you are using the wall maps, the roll-up maps. Do you use them in your lessons?
Yes, ma'am.
Or you use only technology?
No, ma'am. We use wall maps in school.
You use wall maps.
Yes, ma'am.
Students should be made aware of the wall maps. It is extremely important. All GIS organizations have one core mission, a reason to exist, and that is to support the area of focus of the particular geographical pattern. As part of this work, these organizations are committed to building key authoritative data layers to support their mission. So this includes compilation of foundational data on the standard base maps and operational data for their particular geographies and applications which are required. As we proceed in the lesson, we'll go on to some specific examples where GIS is used. Now look at this imagery. Imagery layers enable you to view recent high resolution imagery for most of the world. Multispectral imagery of the planet updated daily, and near real-time imagery for parts of the world affected by major events such as natural disasters. How, like the cyclone Amphan came, how the cyclone was approaching, how many days it took, what was the trajectory it took, where was the landfall going to be, how was it predicted, obviously through GIS. And this very strange phenomena which happened in Maharashtra, which was hit by a cyclone. And you know that in Arabian Sea, most of the time, cyclones don't form at all. They don't form because of the wind direction that we have. And the kind of pressure is required, that is required for the low pressure system to exist and cyclone to begin. So all these imageries can be collected very well by the GIS system. The boundaries and places. You know that these days there's a very major dispute going on between India and China on boundaries and places. You know that? And which is that area which is in dispute?
Galwan Valley.
Galwan Valley.
Galwan Valley. Yeah. And in which part of Kashmir, in Kashmir is it?
Ladakh.
It's in Ladakh. A part of Ladakh, which is also called Aksai Chin, is actually under the control of China. And the line of actual control is the one where the dispute is happening. So the boundaries and places can be drawn very well with the help of GIS data. So these maps layers describe areas at many levels of geography, including countries, administrative areas, postal codes, census boundaries, and so many more. So how a big city, let's take the example of Delhi. How do we know where the Delhi 96 finishes and Delhi 100 begins? So there has to be a boundary. So it is a GIS system which can collate this data that the pin code areas of Delhi, Delhi 17, Delhi 6, all kind of those areas which are, drawn on the basis of the postal codes. Or for that matter, boundaries or the borders of Delhi with Haryana and with Uttar Pradesh. So how this is exactly what GIS does. Demographics and lifestyles. You might not have heard of lifestyle maps. Demographics, we all know. The demographics, they talk about that what kind of population, a population data is collected through demography. That means density of population. What is the urban sprawl? Where are the rural areas scattered? How much light can be seen at night from the satellite? To make you understand that this is where we have the data, this is where we have the population data together in a cluster. So demographic and lifestyle maps in USA and more than 120 other countries include recent information about total population, family size, household income, spending, and so much more. So can you even imagine the sophistication of the GIS, base maps? They provide reference maps of the world and the context for your work. So they are built from the best available data from the GIS community of reliable data providers. These maps are presented in multiple cartographic styles provided for foundations for GIS maps. Here, let me pause for a while and ask you that have you done projections in your classes? The map projections? That on the basis of what projections maps are made? The grids
Yes,
of
ma'am.
latitudes and longitudes?
Yes,
That
ma'am. I did Mercators.
Mercator's. Primarily Mercator. And why Mercator's?
Actually, most of the maps on flat paper are drawn with the help of Mercators, so it is easy for them, easy for my learners to understand. That is why I use.
And also, you might have seen that uh, if you have the other projections like zenithal,
Yes.
for example, or conical projection, then what happens? They have a particular focus on a region. So it is a marketer which is basically spreading out the map in the latitudes almost 66 degree north to 66 degrees south.
Yes.
So that is the reason why marketer, where most of the countries are located, is less distorted. But one thing you must understand that any map drawn in the world will have some kind of actual distortion.
Mm.
Without distortion, you cannot make a map. The only thing which is the real replica of the world is a globe.
Yes, exactly.
That's the real thing. But you've seen the globe and you cut it into pieces and spread it out, you will find that how on a Mercator projection, the northern part and the southern part, it gets distorted.
Distorted. Yes, ma'am.
Greenland is not as big as a lot of people think.
Yes, it is shown bigger on Mercators.
It is shown bigger on Mercator. If you want to see the actual size of Greenland, then you will have to draw a conical map, which is focusing the light like this. If you put light over on top of the globe, it gives you the conical projection. So all these projections and all those maps, which are based on the projections, are actually distorted copies of maps. However, maps are so handy, they are so useful that maps cannot be replaced. Globe, as you know, can't be, is not portable, you can't carry it everywhere. And how do you plan anything on the globe? Where is the city located on the globe? Like a dot. But where is the city on the map? You can have not only map of Delhi, you can have a particular region of Delhi. You can even have a map of your school on actual earth, on actual land. And that's what the Google Maps is doing. So that is why the reliable data which comes through these base maps, through GIS, they are a wonderful way of collecting information. The idea for these videos to be shown was that you know that what amazing careers are present in geography through GIS and how we can motivate our students to take up the information system in such a way that you not only have to have a good hang of geography, the traditional geography, but also the latest technology that you use in geography. And that is how we can motivate our students. So that is GIS for you. You could be a forester, you could be a conservationist, you could be a climatologist, you could be a specialist in cyclone and tornadoes and typhoons and anything. So here the sky is the limit for GIS. That's important, and I'm sure you must also have seen that in one of the in this video of Gabon, that what kind of rainforest the person was going through, and you might have noticed the dense foliage where not a ray of the sun passes from the top. and the overhanging creepers and lianas that grow, and the growth on the forest floor, and the kind of the insect world that we have in the rainforest. When you look at these natural images of so many beautiful geographical places in the world, you realize that we're lucky indeed that by teaching geography in our classrooms, actually, we are exploring the world. The more we explore the world, the more we know about it through these various, readings and researches and videos. We get to know that we have a very major task on our hand to make our students understand that it is extremely important for a geographer to stay interested in the beauty of the world, that what the world has got to offer to us, and how we can, as a geography teacher, motivate our wonderful students to take up these topics.